Hi everyone, welcome to our event. This event is brought to you by DataTalksClub, which is a community of people who love data. We have weekly events, and today is one of such events. And actually, this week we have quite a few events. So also later today, we will have a workshop about time series prediction. So we will be doing stock market predictions. And then tomorrow we'll have another podcast interview. So check it out. Actually, this is where you can find out more about the events we have. There is a link in the description. Then do not forget to subscribe to our YouTube channel. This way you'll get notifications about all the amazing streams we have, including the ones we have today, tomorrow, and and finally, last but not least, we have an amazing Slack community where you can hang out with other data enthusiasts. So check it out. There is a link in the description too. And during today's interview, you can ask any question you want. There is a pinned link in the live chat. Click on that link, ask your questions, and we will be covering these questions during the interview. So that's the usual intro I give. Now I have the questions in front of me. And if you're ready, we can start.
Yep. I think I'm all set, Alexei. Yep. Let's go for it.
Okay, let's roll. This week we'll talk about digital data warehousing and FinOps. We have a special guest today, Eddy. Eddy is a staff data engineer at Kinaxis. Did I pronounce it correctly?
Eddy Zulkifly and Kinaxis. Yep.
Kinaxis, okay.
Yes.
Where he's building a robust data platform. He has more than 10 years of experience in data, and he gladly shares his experience as a mentor and as a teaching assistant. Previously, he worked as a senior data scientist at Home Depot, where he specialized in e-commerce and supply chain analytics. So welcome to the show, Eddy.
Thank you, Alexei. It's a pleasure to be here. So I guess I'll just introduce myself briefly. I think in terms of kind of like Alexei, you kind of like talk through a little bit of my experience, but I'll just say in terms
Maybe
of
first,
my.
there's one thing I want to mention because the questions I'm going to ask you today
Yep.
are prepared by Johanna Bayer. So thanks, Johanna, for your help. And usually there is something I ask you to introduce yourself. So I'll do this now, and then you can do this.
Oh, okay. Got it. Yep.
But don't worry. So we release this as a audio only version, and it will be edited. So
okay, sounds good.
So before we go into our main topic of digital data warehousing and FinOps, let's start with your background. Can you tell us about your career journey so far?
For sure. So in this case, I will definitely state by saying my journey into data wasn't exactly a straight line. Initially, I was supposed to do chemical engineering, but midway through learning about my engineering options, I was pulled into industrial engineering because of the psychology side, basically how to design systems for people, which is essentially user experience. I didn't know it then, but kind of like that process of how do you build systems for people really shaped how I approach data today. So my first foray into my job wasn't even in technology. I started deep inside supply chains, working inside distribution centers, figuring out how to optimize space for the warehouse, working with Excel macros to optimize pallets, figuring out how many containers was going to arrive next week, next month, and that relates to how many people we're going to staff inside the warehouse.
It's
I did
demand forecasting, but you did
yes,
this in Excel.
yep, pretty
Amazing.
much. Yep, I moved through a lot of different roles. I did supply chain, e-commerce, merchandising, business intelligence. Early on, however, it wasn't necessarily Python and SQL. It wasn't kind of the standard data analytics remote role that everyone thinks of today. My first role was at a distribution center. I had to move out of the city. I had to come into the office, but it was a very great experience because I learned kind of like how to apply data in a real life context. Looking back in my career so far, I realized that was a very solid foundation for analytics. Excel is still, even today, the universal language for business. Regardless of whatever nice dashboard you build, the main question stakeholders will always ask, can I have this in an Excel file? So it was a very productive experience for me because whatever that we built, we had to summarize or put it in an Excel file, or if you had to convert it into a PowerPoint deck, it's going to end up as a chart or as a bullet point. I would say that my journey into data mainly came out of curiosity. I didn't necessarily have access to Tableau, so I had to pick up Tableau Public, and I learned watching from YouTube and from different creators. Eventually, my org had access to Alteryx. I really loved it because you could do analytics really quickly using kind of like a low-code approach. I even got certified. Eventually, within my organization, I moved into Google Cloud and BigQuery. I also was taking a master's in analytics at the time, which led me to discovering Python, data build tool, and building the modern data stack using kind of the ELT approach that we see today. So right now, working as a staff data engineer at Kinaxis, I'm mainly focused on building data sets and dashboards for our FinOps team to optimize cloud spend, making sure that our data platform runs efficiently. The way how I think about FinOps is it's kind of like process optimization again, similar to my first role working at a physical warehouse, but now I'm applying it in the cloud or in a digital warehousing context. So a lot of the things that I've learned still apply even today. And looking back, it was just being open to learning and trying new things out. And over time, I think you build a lot of these skills as you go down the technical chain from Excel all the way to kind of like Python, Git, and the command line.
And what also picked what I also noticed is right now you are a data engineer, but previously you were doing data science. So how did the switch happen?
So in this case, I also kind of like preface. I think my title is like a senior data engineer, but I kind of like moved from a business analyst role into more of like a data engineering role.
Okay, so you
And yeah,
understand.
yeah, yeah. So in this case, like working as a business analyst, it was just mainly about building dashboards. So that's where I picked up enough about Tableau Public. I uh, attended some of these learning events that Tableau, or at least like some creators would organize. It was called Makeover Monday. So somebody would give you like a data set, you can just copy it over, and then based on that, you would create narratives and create the corresponding charts. It was it was a useful exercise for me to just figure out how would you kind of like present all this information. And then moving into data engineering, it was also kind of like the understanding that I had a really good manager at the time, and she told me that I think whenever I talked through about Tableau or the dashboards or whatever Alteryx pipeline that I built, my eyes would always lit up. So that was probably when I realized that my skill actually came from working on the technical side of things. So that's where I feel that I kind of wanted to pivot my career more into the back-end side of data, which is just data engineering. Yep.
And it's actually one of a few common questions we have in our data engineering course. So our course is designed for people who are coming from the software engineering background. But the question we get is like, I'm a data analyst. Is it going to be easy for me to become a data engineer? And I think it's a pretty relevant background, right?
Yep.
So from an analyst to become a data engineer, correct?
Yep, absolutely. And I'll definitely shout out to what you guys have done as well, because I think through kind of like my connections at my organization at Home Depot, some of the folks that was working from the US told me about DataTalksClub. That's how I heard about this data engineering Zoom camp. And I remembered, I think it was such an interesting approach because the first thing that you guys were teaching was Docker and Terraform. And for all of us kind of like data folks, it's like, what is this? It was kind of like working through the command line, and it got like for us a little bit what's it called, overwhelming, because I guess most data analysts work on a UI. So I
Yeah.
think I came from that Alteryx background. You get like a low code approach, but in this case, because you're transitioning directly to a command line interface, there is kind of like that bedding in period. But now I think as a function of just getting used to working in kind of like that data engineering mindset, Docker or Terraform, eventually all the languages are just the same, and you just figure out what you need to do, right? And I think that that's kind of like the most interesting part about, I guess, working in the data engineering space is it doesn't really matter how you start, but once you get comfortable with one language, a lot of that just carries over to the other.
And funny thing with Docker is we kind of expected that people knew it, people who were signing up. So when we were building the course, we thought everyone knows Docker. Like we'll just have it just in case. So it's a prerequisite, as a sort of like warm up week where people who don't know Docker, they will, pick it up, and then the actual stuff will start later. but it turned out to be the most difficult week. And yeah, we did not expect that.
Yep, and I have a similar story to share as well because so within the Docker space, I had folks in Toronto talking to me about dev containers. So in this case, development containers. I've been to a couple of meetups in the city where when they want to teach you tutorials, you set up or they give you like a dev container JSON, which I read about, and it's kind of an abstraction of Docker. But even then, because it's all in JSON, and when I try to explain to data folks, when they see it, it's like, oh, I've never worked in this before. I'm not in DevOps. And I'm like, this is not, I mean, I wouldn't call this DevOps per se. It's just kind of like configuring like a file. But it's a very different approach, I think, working in Docker and working with these development containers. So it does require some form of getting used to, I would say.
And understandably, if before all you did is business analytics, and now all of a sudden you need to do Docker, like everything that is related to this kind of stuff feels like, oh, it's DevOps, it's something complicated.
Yep.
And then
For
once
sure.
you get into this, then you start understanding, okay, like this is not DevOps. This is like DevOps is like this other complicated thing, but this thing I already learned.
Yep, for sure.
Yeah. So you work at Home Depot, and for me, Home Depot was so they hosted a Kaggle competition a while back, and for me, it was one of the first Kaggle competitions. It was it about demand forecasting? I don't remember, but it was like awesome. So I remember taking part in this competition. So it's really cool that you were doing that. Can you tell us more what exactly you were doing there? Was it already, was it still you were working in logistics and building like physical warehouses, or you were already moving towards the digital ones?
Yeah. So in this case, my time at Home Depot, I think, was a discovery process for me just to explore the different aspects of my degree. So one part of my degree was talking about logistics and optimization. So I had phases where, while I was working in the warehouse, and I think, like I say, I want to give some context to the rest of the folks. At least the equivalent of Home Depot in Europe would be something like an OB or a Bauhaus. I did my research to figure out kind of like what's equivalent. And then in Southeast Asia, where I'm from, there's also Mr. DIY or Daiso. So think of your screws, your hammers, outdoor furniture. The most interesting time that I felt while I was working at Home Depot was usually during the holiday seasons, during September and December. Usually that's when Home Depot in particular would sell like a lot of different Halloween products. So we had like skeletons, we had dinosaurs kind of like inside the warehouse. So a typical workflow for me during that time period was forecasting based on the orders, how many containers of goods were arriving, what did they come in? Did they come in multiple boxes? Were they multiple products in a box? Because that would kind of like change how we would treat the product inside the warehouse. Once we figured out the size of the boxes, we need to figure out how much space it would take inside the warehouse. So from there, you had like different approaches of, okay, so if it was going to take X much space, how much labor is required to store it, and then down the line, when you needed to send it to the stores, how many people would be required to kind of like pick and package the product and send them to the store. So there were a lot of different questions that we kind of looked at, and we used a variety of different tools. We had something like an Excel macro to figure out what's the best configuration to store these products. We also had, and in this case, I didn't realize it at the time, but when these products needed to be shipped, there was this whole process called like preload optimization, where it was up to engineers and folks in the warehouse to basically understand what were the requirements at each stores, figuring out how to maximize the trailer space given the sizes of these products. So we kind of essentially did in the integer knapsack problem, but by hand using Excel. So it was very much like manual problem solving that we kind of did at the time. Realizing kind of like looking at my degree and knowing what software exists, now we have companies like Kinaxis that kind of like provide software that allows you to just kind of like do that automatically. So it was interesting to know that as much as it was a lot of manual work to do this, there's also kind of like automation that helps you kind of like do the job
Mm.
easier. Yeah.
Yeah, interesting. So you must be a pro at Excel macros.
I had to pick up a lot of things because that was kind of like the initial foray into like programming. You had to kind of like get familiar with macros. And there was always a way you could just press the record button and then like press a bunch of different
Yeah,
cells,
yeah,
and
yeah.
then you'd see your code, right? So that's like, okay. And then afterwards, you would look into the proper way to how would you define kind of like this object, and you change it a little bit differently, right? But that was also how I guess
This is
I started,
how I did.
programming.
Yeah.
Yeah.
So I remember I even created a website from my. So I had um, so I had a kind of database of. Do you know what bootlegs are? Music bootlegs. So when you go to a concert
Mm-hmm.
and you film the performance from your video camera,
Mm-hmm.
so it's like kind of fan video. It's not official video. So these videos are called bootlegs.
Mm-hmm.
And I was exchanging. So I was filming them, and there were people from, I don't know, Austria or Australia or the States who were also doing that, and we would exchange them.
Mm-hmm.
So I would send a DVD with my recording, and they would send a DVD with their recording. So I had a catalog, a database with all these bootlegs. And with Excel, I could make a website. Like I had a macro that publishes an HTML page, and then using SFTP uploads it to a website. So that for me back then it was like mind blowing.
Oh, okay, that's interesting. I have a similar story to share down the line, but we can talk about it later. Yeah.
But like Excel is surprisingly
Mm-hmm.
very powerful when you think about that, because
Mm-hmm.
there are so many things you can do. Like probably you can even play, I don't know, Space Invaders or Doom or whatever in Excel.
Mm-hmm. Yeah, yeah. I think I've seen people make art, or there's even like Excel, like Excel competitions where there's some sort of formula or there's some sort of use case, and then people have to build like Excel models for it. So it's definitely something that, if you can do it faster, there's people that are willing to pay to turn it into a competition. Yeah.
Yeah. So I just, while you were talking, I checked the competition. So the competition was Home Depot product search. So it was about predicting the relevance of search results on Home Depot. So there were like it was for the website. People type in some search, and then there's like a pair search product and relevancy, and the task was to predict the relevancy. So I think it was for me one of the first exposures, like the first time I got exposed to these kind of problems. Yeah, that was pretty interesting.
Yeah, yeah. Okay. That's pretty neat. Yeah,
Uh,
I think that's probably related to cosine similarity, and I
yeah, yeah,
believe
yeah,
there was like,
exactly. Yeah,
yeah. Okay.
and I actually didn't realize that Home Depot is like Obi. I thought it's an online store. Because for me, like I took part in these competitions and I know the name, so they have a big team, and I thought, yeah, must be just an online store where you can buy screws. But it's actually a bunch of physical stores too, where you can go
Mm.
and buy all this stuff. Okay,
Oh yeah, yep. There's a lot of stores in Canada, the U.S., and Mexico, so it's
I
quite a few.
see.
Yep.
Mhm. And there, it's a huge store, and you need a warehouse to keep all these things and then bring them to the stores. And this is where your work was optimizing this stuff, right? The like
In
like warehouses, right?
Well, in this case, it would be kind of like on the back end. So I guess maybe I can give some context of like how products got into the store. So
Yeah,
we have the distribution center that stores kind of like all the bigger products, and then once it was shipped at the store, that relates to my time working on the merchandising side. So a lot of these stores have like planograms. So basically, configurations of where would you put the products in the stores, and like there's a whole science behind it. So there were like heat maps that could generate kind of like where the most sales was coming from, and then there would be a whole team that was dedicated to figuring out how would you optimize the space even inside the stores to maximize kind of like your returns. So that's why you have certain products that were kind of like closer to the exit. You had certain products kind of like at the back. So similar kind of like how grocery stores would build kind of like their stores to put the milk at the end, or stuff that you would usually buy at the end because they want you to walk as
yeah.
much as possible around to maximize your revenue. So I thought it was pretty interesting that we have kind of like those principles there as well.
Did you also use Excel for that?
In this case, I was in a different team that they were using kind of like more of Alteryx and Tableau, but we actually did also have our own in-house software that would basically kind of like map the sales to the layout of the individual planograms at the stores. So there was a whole software thing behind that as well. Yeah.
It's called merchandising, this art or science of placing
Yep.
products.
The specific term was assortment planning. So each, yeah.
Okay.
Yeah. So in each store, each store's assortment plans were slightly different because the different regions in Canada kind of like all behave slightly differently. Some areas, people preferred buying certain types of products. So a lot of based on the sales, we would tweak kind of like the planograms based on how people buy their products. Yeah.
Did you work in an actual physical warehouse? I didn't mean like carrying stuff, but like
Oh, actually,
optimizing.
I did that too. Yeah, yeah.
Yeah.
So my
Ah,
first job at Home Depot was literally at a distribution center where people, it was very much like people kind of like loading stuff into the racks, and then kind of like closer to the end of my time at Home Depot, I was working closer to the corporate side where I was looking at planograms at the stores and eventually moving into kind of like the data analytics team there as well. So I've had experience on both sides.
didn't you use robots from Amazon Robotics?
That one, I'm not sure. Probably at the time, I don't think they were testing that out at the moment. But at the same time, I
Yes.
don't think we were. Yeah.
So Amazon Robotics is a company where they have these bots or robots that can move around your warehouse and move things. And before it was called Kiva Systems. And
Mhm.
this was the first company where I worked as a Java developer. And I think maybe I am wrong, but I think Home Depot was one of the customers, but maybe it didn't go anywhere.
Oh, interesting. Okay, so I
Because
guess
Amazon
potentially.
bought, and I guess like after Amazon bought this Kiva Systems and it became Amazon Robotics, maybe all the clients couldn't use it anymore. So because Amazon just took all the robots.
Okay, that's interesting. So I guess I'll probably also distinguish that like there's Home Depot US, so that's like the I think the bigger Home Depot, and then we also have small subsidiaries. And in this case, I worked for the Canadian one. So I
Okay.
guess it might have been a little bit different, at least on that side. Yeah.
Yeah. But your work at a later stage of your career involved optimizing these, how do you call them, distribution centers, which is practically a warehouse, right?
Yep. It is very. Yeah, it is a warehouse. Yep. Mhm.
And then we also wanted to talk about digital warehousing. So
Mhm.
what is that and how do they, so maybe we start first with physical warehouse. So warehouse is space with racks where you have products. And there are
Yep.
some processes for people or things or I don't know, robots
Mhm.
to take the things, the products, and move them to,
Correct.
I don't know, there are
Yep.
carts going,
Yep.
trucks going
Mhm.
out of the distribution center, right? So
That's
you
right.
need
Yep.
to get this product from a rack and move it to the
Correct.
car, right? So
Yep.
that's
Yep.
a
Exactly.
physical warehouse,
Yep.
right?
Yep. Mhm.
So
Yep.
what is the digital?
And so I guess in this case, I'd like to thank you for kind of like that context there. So in this case, the way how I think about digital warehouses is, and I remembered kind of like having this realization. It's like I've worked in my Home Depot for so long that I worked in a physical warehouse, and I remembered the last role I had at Home Depot as a senior data engineer was, well, technically I'm still in the warehouse, but now in a digital one because I kind of like thought through it. It's like, okay, so when you think of moving data, your ingesting data. So think of that as kind of like the trucks that was going to deliver data into your warehouse. So in this case, we use Google Cloud, and there's like BigQuery to land the data into the warehouse. Within the warehouse, you have internal processes. So we had like internal orchestrators to kind of like run SQL queries to kind of like transform and process the data. And then when you kind of want to send the data to stores, in this case, you're sending it to kind of like a downstream consumption layer, which is in this case like a BI tool. So for example, it could be Tableau, it could be Looker, it can be many other things. So that's kind of like how I came to the conclusion that, okay, so in this case, the data engineers are the people that kind of like build this, the pipeline or the Python scripts that move the data from the source into the warehouse. And then inside the warehouse, you have transformation tools, systems such as a data build tool to transform the data, clean it up, put it inside the racks, put it in like put it inside a rack or put it in a different table to organize it a little bit. And then at the end, when you want to send it out, you have like some sort of service account, or you have some sort of process to land the data either in Looker or in Power BI. And there's somebody that's building kind of like the final kind of like dashboard that the end users will see and they will use to generate insights. So I guess that's kind of like where the analogy of working in kind of like working in the digital warehouse is quite similar to a physical one as well.
Just occurred to me that in the word data warehouse, we have the part warehouse, which is this distribution center, right?
Mhm.
Yeah, that's interesting.
Hmm.
It's like the goal of a physical warehouse is there are products, like there are huge trucks that come in with a lot of products. Then you need to put these products in racks in such a way that the products are easily accessible.
That's right. Yep.
And then they're accessible, so then they can be moved to smaller trucks that already go to stores, or maybe bigger trucks, doesn't matter, but like they're already organized in such a way that you need to, okay, like I need X amount of this, Y amount of this, and then you just, because it's easily accessible, you can easily fetch this data. And in the same way, we do it in the physical warehouse or digital warehouse. The data is well organized. That's a really nice analogy. I never
Mhm.
thought about this.
Yep.
Cool.
Uh, yeah, and I guess we can also talk through a little bit, like at least based on my experience of what made the differences. And I think this is, I think for me, the biggest kind of like takeaway between a digital and a physical warehouse was just that I think because my first role was in process improvement, it was basically understanding the processes, and then there's the whole change management piece that because the physical warehouse is kind of like managed and run by people, teams, and departments. There's always a process where you need to basically run your changes through the line of command, and it will take a while, and you have to teach and educate people. And another way to think about it as well is like inside the warehouse, if you say, for example, you need more racks or you need more space, that's it will probably take a couple million dollars. It requires like people to basically break some walls and add new ones. So in terms of like the feedback loop, it took a while, and then in terms of like the actual cost that's required, it does require a lot of resources. And then when I think of kind of like the digital warehouse, it's a little bit different because in this case, if you have a new data requirement, you can quickly create a new table, create a new rack. You can optimize it then and there, and you can also get feedback pretty quickly. You can create your model, you can send it out, get feedback, you can quickly iterate. So in this case, like the feedback loop was a lot quicker in the digital warehouse. Another thought is in terms of getting information about the systems. So in this case, inside the physical warehouse, you would rely on either internal systems. So we had like internal systems to track the processing of, in this case, cartons or boxes. You also have, you can use your eyes to make observations of like how people are working through the products. But when you look at a digital warehouse, because you can't see it, everything is kind of like in the cloud, so to speak. It requires observability systems. You need monitoring to see, you need to set up tests to see if anything is breaking or any assumptions that you set on your data is failing. So it's a bit harder, but it also requires more tooling for you to kind of like see what's happening behind the scenes.
Interesting. Can you tell us more? What exactly do you do now as a staff data engineer at Kinaxis?
Yeah. So in this case, my day to day definitely kind of like runs the gamut between kind of like working with the business partners and I guess working more on the technical side of things. One thing that I've learned, at least through the process of implementing and building kind of like these platforms, one of the things that I try to do is really understanding the business requirements. So right now in the analytics space, there's this whole thing about understanding or building a metric tree to understand what are the metrics that the business cares about, and what are the levers that are correlated and associated to it. We tried kind of like basically implementing an exercise of building a metrics tree for a FinOps team. So understanding what are the cost factors inside a data warehouse, what are the cost factors kind of like inside the cloud platform, what are the things that you can control, what are the things that you cannot control. And it was actually a very insightful activity just to kind of like like for everybody to share kind of like their knowledge and experience and perspective, because once you kind of like put all of that together, I think it gives everybody a good frame of reference on how to look at data and see how you can kind of like build data sets that kind of like help answer these type of questions. Another thing was also um, in addition to building metric trees, it was also, and this is something that I kind of like picked up from Zach Wilson's course, which is kind of like using like a data spec. Because what I've learned when you work with a variety of different teams is that usually business requirements can be pretty vague, and it's important for you to really try to contextualize a lot of the requirements into hard technical data requirements that you can kind of like figure out how does your business requirements map to data pipeline requirements, metric definitions, the frequency of your pipelines, tests, assumptions, and any unknowns. Because once you kind of like have all that together, you can kind of like communicate back to the business, this is what we're building, is this good, yes or no? And I think have a part of that getting alignment piece is probably the most important part of data engineers, because then once you know what needs to be built, at least you have a sense of what direction you're going. So I found that kind of like really important. That would be kind of like one part of my job. The other part is, in this case, we're standing up kind of a digital warehouse. So setting up our stack essentially using cloud platforms and using kind of like a combination of open source tools to kind of like maximize the business value, but also making it easy to maintain for the engineers and the analysts within our team as well.
And while you were answering, I checked what Kinaxis is actually doing. So it's a platform for supply chain planning, right?
Mm-hmm. It's
yeah.
supply chain, and I think all aspects of supply chain. So I think inside kind of like the website, there are a bunch of different modules that we also provide. Yeah, so there's, I think I saw transportation and I think orders. So it is kind of like run kind of like a variety of different use cases within the supply chain. Yeah.
Mm-hmm. And for you, you already had the background in supply chain. So for you, all these things, all the how to say business domain, it made sense for you, right?
Mm-hmm. Yeah. In this case, like I have a sense of kind of like what problems our tool solves. But in this case, I'm working more on the infrastructure side of things. So figuring out like how would you optimize costs for deploying all these tools to customers a little bit more. Yeah.
Can you tell us more? What exactly do you mean by optimizing costs? Is it so? Let's say I work at I don't know, something similar to Home Depot. I don't know any names, but let's say there is a company that is similar that needs a solution like that, right? Supply chain planning. So it's a rather large chain, and we have warehouses, we have stores. So like we have clients, we need to optimize that, right? And now we want to use something like Kinaxis, right? How do we optimize costs? Like what does it exactly mean in this particular case?
Oh, so in this case, I think then we kind of move into kind of like the realm of what is what is software as a service. So a lot of the solutions that we kind of like build, all in this case, yeah, a lot of the products that we offer come in. Well, everything that you build eventually has to run in some sort of server or data center. So for any sort of component, there must be like some requirement of some sort of virtual machine that has like some set of RAM, some set of storage. There's also considerations where in terms of kind of like when you're storing data in different regions, we have clients globally. There's a bunch of different local data regulations, so you need to store data in certain places. And there's also in this case like figuring out how do you keep your data secure and keeping your data backed up. So there's a lot of internal processes that we also have to keep in mind to ensure that our customers' data is safe and is protected. So it's just figuring out how do you do that in the most cost efficient way possible.
Yeah, so it's optimization, cost optimization for you, not for the clients.
In this case, it would be on our side as well. Yeah.
I see. Because the impression I got was you offer a bunch of things, and then the customer comes and says, "Hey, I want your solution," and then you work with them to figure out what's the best setup for them.
Oh, I mean, in this case, we also kind of like do that too. Like when you sign with a client, there's a whole engagement process where you're working with the customers to kind of like take their data. We would basically kind of like have a process to integrate their systems to our platforms. And there is kind of like a whole team that's just dedicated to kind of like maintaining that and then piping it into kind of like our platform as well.
And this is probably related to FinOps, right? So cost optimization. And I remember, so in the previous company where I worked, I think it was the procurement department. So basically all the tools we needed to buy, like, I don't know, GitLab or Google Workspace or whatever. Like there was basically like if I needed a tool that costs money, I would need to talk to these people to figure out let's say the logistics of this process. So that was the procurement department. And I think they were doing this kind of thing. So for example, when it comes to AWS, so in AWS, you can have like special contracts. You can think like how many things in advance I want to order, like there are on-demand instances. And you can say, I want, I don't know, 1,000 on-demand instances with this kind of characteristics, and then it becomes cheaper. So this is optimizing costs. And probably when you deal with AWS and you say that this is the amount of money I want to spend, this is the things I want to get, you may have special contract. So is this FinOps?
Yes, that is correct. So I guess one of the things that our team also does is from using kind of like the data sets that we create, we need to understand the cost and usage of our systems. And then from there, figuring out how do you kind of like negotiate with cloud vendors to optimize the costs, because usually we would have kind of like an expectation on how long our servers would run. So you can basically negotiate that discount to get a lower rate. So yes, that is true.
It's pretty similar to what I just described, right?
Yeah, reservation instances, and yeah, it is kind of like a part of kind of like the FinOps process as well. Yep.
So can you tell us more about what kind of problems you solve there and what kind of solutions you use for solving these problems?
Well, in this case, when it comes to kind of like looking at that, it really is a function of understanding cost and usage. So there's one part where I think it does require for you to kind of like be have a good understanding of kind of like the business, understanding what's expected to happen in the next couple of months, because then you kind of want to forecast out or understand kind of like what is going to happen inside the cloud platforms. In this case, the things that generate a lot of costs would be running like virtual machines on servers. So in this case, you want to make sure that you have a good handle on when and how long you would probably need to stand up like your virtual machines and your servers. So having kind of like that as one input is important. And then from there, you'd also need to understand kind of like your deployment requirements. So your virtual machines can be configured to be at a certain level of RAM, to a certain level of storage. So figuring out what are the requirements for that, because all of that are different cost factors. Another consideration is also depending if you're using something like Linux versus Windows. So depending on the different operating systems, some have licenses, and the cloud platforms would also give you kind of like certain discounts or bundle licenses together, so you get two licenses for the price of one. So understanding kind of like how the cloud platforms give you incentives and promotions um, based on, I guess, how they want to sell their product. So I guess we can talk a little bit about the variable nature of pricing in the cloud. It's a very complex topic because there's so many different tools online that you can find in terms of how would you price like a certain product or service. So you would kind of have to like translate what the engineers are building into kind of like the components, and then from there you'd also have to figure out how much like RAM do you think you're going to use, how much gigabytes and all of that. All of that translates into some sort of price. And then if you kind of like go through the exercise of running kind of like the same specs and models across all the different cloud vendors, you can try and see which one offers the best value. So that would be kind of like the exercise that we would kind of take as well as part of a FinOps team.
Okay, and then you also evaluate multiple clouds, right? So you know the requirements, you know that you need X amount of virtual machines with certain characteristics, and then you can check what kind of deals you get from Google Cloud, from AWS, from Azure, whatever, right?
Yep.
And then based on that, you can decide where you go.
That's correct. Yep.
Interesting. And when it comes to the tools or solutions to these problems, I guess it sounds like demand forecasting to me, right? Or
Yep. There's demand. Mainly, it's I think yeah. There's demand forecasting. There's inventory planning. And there's a bunch of other different features. There's also I think a notion of like doing kind of like what if analysis. So in Excel, you know how sometimes depending on kind of like the variable that you put in, you get like different outputs. So I guess this is kind of like a very basic version of the optimization model. So we kind of have something like that internally that kind of like looks at the different parameters and it adjusts them to figure out how do you maximize your revenue or your profits.
Mhm, mhm. So inventory planning, demand forecasting, this sounds very similar to the physical world, right? Like all
Mhm.
these things we talked about, like what was that? Distribution centers and
Mhm.
okay, interesting. So again, your experience from that part of your career, from that point of your career, was helpful here too, right?
Yep, absolutely.
Where can we learn more about this FinOps?
Yep. So there's a FinOps Foundation, and in this case, I think they are kind of like the de facto player in the FinOps space. There's like training courses that you can go online to kind of like upskill yourself in learning about FinOps. So right now, I'm also working my way towards getting like certifications as a FinOps practitioner to pretty much understand kind of like the whole aspects of FinOps. It does feel like they give you kind of like a nice piece of it's a nice document like consisting of the framework of kind of like what FinOps teams do. There's a bunch of different shared principles. For example, like when you have cloud costs, you want to make sure that you make your teams that are using the cloud accountable for their costs. So you have to set up like tagging systems to make sure that whatever VM that's being set up, it's tied to a specific department. And then there's a whole process of just reviewing costs. So there's that. And there's also, I think, in terms of the FinOps side, you want to make sure access to data is timely. So that's kind of like where in the data engineering space, you want to make sure your data is coming in fresh every day, loaded into kind of like your data set. So you can do kind of like a monthly or weekly reporting as required.
Do I understand correctly that FinOps is so? Let me take a step back. So at the beginning, when we just started talking about FinOps, my impression was that it's about cost optimization in general. But the more we talk about this, the more I realize that it's related to more specifically focuses on the cloud, right?
Yes, correct. Yeah.
So
That.
FinOps
Mhm.
is how we use the cloud in the most cost-effective way, right?
Correct. Yeah. And I guess that kind of like opens up the opportunity where I feel like working in the physical warehouse. I mean, if you wanted to build up a rack, you would need like some experience to, uh, get the resources to turn like iron and steel into a rack. But in the cloud, you can kind of like learn a little about data, like cloud architecture to figure out how would you kind of like make your processes more efficient. So there's this notion of kind of like instead of relying on servers, you can take like a serverless architecture or just deploy containers. So in this
Mm.
case, rather than paying for a fixed asset, you just kind of like pay as you go. You can use in like the different cloud platforms. There's a notion of like a cloud function or a Lambda function that runs something as and when you need it. So I just found that really interesting that I think if you know enough about the cloud or if you know enough about architecture, there's also opportunities that you can work with your team to figure out cost optimization opportunities. There's a whole space about like storage. How do you minimize costs? There's also um, being able to kind of like reduce your costs by changing the type of storage that you're using inside your respective clouds. So I think in Azure there's a hot storage and there's cold storage. In GCP there's similar definitions as well. So there's a whole thing about just understanding the different aspects that you can cost optimize in the cloud and then just implementing it. And that's kind of like where you can also generate savings.
And the other thing I was thinking about is, there's this thing called DevOps.
Mhm.
And then later we had MLOps and DataOps, which is, in simple terms, MLOps is machine learning operations, which is kind of DevOps for ML, and DataOps is data engineering operations, which is, yeah, DevOps for data engineering.
Yep.
And my understanding is FinOps is the completely kind of parallel thing, so it's not related to DevOps per se. It's just the name is kind of similar.
The name is kind of similar, but I think the more specific term is called cloud cost management. So in this case, it's actually just more of like I would say it's more of a kind of like a business type role, but you can kind of like spin it into something that's more technical if you want to. So there's kind of like the interesting part about FinOps is I guess it can be as technical or as business focused as you want. Yeah.
And when it comes to the technical focus, what kind of tools and technologies one needs to know in order to actually, say I know FinOps?
Well, in this case, I think knowing FinOps is would consist kind of like the list of different processes that is related to FinOps. So in this case, um, there's like a open source tagging software that you can use to implement tags inside your cloud infrastructure. So there's kind of like a notion of that. And I guess in terms of after you kind of like tag your resources, then you kind of like rely on the more data processing approaches. So in this case, you would have to know a little bit about data warehousing. You'd have to know about setting up ingestion systems, your transformations, and the visualizations aspect. And I think in terms of the visualization aspect, it's tied to kind of like the use cases for FinOps. So the great thing that I've also learned about the FinOps Foundation is there's this whole development ongoing for focus or open usage cost specifications. So the pain point that a lot of FinOps folks have is you have the three major kind of like cloud platforms: AWS, Azure, Google. Everyone reports their spend a little bit differently. They use slightly different names. They have slightly different calculations. So there's an initiative within the FinOps Foundation to kind of like create a standard data set across the cloud platforms so that you can kind of just use all three and merge them into a single one. So there's kind of like that piece that's ongoing within the FinOps Foundation, and we're also kind of like understanding ourselves how do we implement that within our organization to make the reporting costs a lot easier.
But oh, while you were saying that, while you were
Mm-hmm.
answering my question, I realized that even though it's a thing that is kind of not related to DevOps per se, it's parallel thing. Still, in DevOps, the focus is not just on tools, but on processes. Like how exactly we as a
Mm-hmm.
team make sure that we deliver the best possible software, it's reliable, it's testable, like all these processes, and then like how we as a team work. And then like we have this continuous integration, all these tools like testing, all these approaches. And what you just described sounds quite similar, even though like it's not DevOps, but again, like the focus is more on processes. You want to, how to say, streamline maybe all these processes, and then there are
Mm-hmm.
tools that help you with that, right?
Yep, exactly. Yeah, I think you hit the nail on the head there in terms of the processes piece. Yeah, and in this case, yeah, because working in FinOps is still working with data. A lot of those data ops processes like CI/CD still apply in this case. So even like just standing up like an action to just check based on any new data set that you create, does it impact like any deployments or any dashboards that you have downstream? Similar process as well, pretty much.
Mhm.
Yep.
And if we go back to my previous question when I asked you what specifically do you do as a staff data engineer, and you were talking about business, and what was the second part? Like, FinOps. Like, I just, given that the discussion we just had about FinOps,
Mm-hmm.
maybe we can go back and revisit what you do there.
Oh,
Uh,
okay. Yeah. So in this case, like I definitely have like in addition to that, there's always as part of a data engineer, you're also kind of like working on the technical side of things, fixing or deploying pipelines, working through bugs. There's also the part where in this case, because we've set a kind of like our data platform, it's also to train the data team on how to use some of the open source tools that we are developing and how do we implement data ops in our processes to ensure that our data sets are of good quality. And then it's also, I think, the interesting bits as well within the FinOps space is there's also a notion of defining FinOps metrics that are important to your business. So in this case, it would be a concept called like unit economics, understanding what are the main metrics that you want to focus and optimize on for your specific organization.
so do I understand correctly that what you do is building a data platform for FinOps, for making these decisions, for optimizing costs and things like that?
I think that's pretty much pretty much it. Like we have kind of like all this data that's coming from the cloud platforms. We have to understand kind of like what the business logic or our business logic and the metrics definitions, and then we would basically like implement them to generate kind of like some sort of unit economics that's used to kind of like evaluate where we're performing in terms of cloud performance. Yep.
So at Kinaxis, there is this FinOps team, and you as data engineers work with them to make sure you optimize all the spendings.
Mm-hmm. Yep.
So in this case, the business owners, or how to say, the business people you talk to, they're the FinOps folks, right?
In this case, well, we're generating kind of like the reporting, and we're working with the business users. So the people that are developing in the cloud, the people that are setting up infrastructure in the cloud. So we are working with engineers, we're working with product owners, we're working with all folks in the business to kind of like manage and control our spend.
Mhm. And I think while you, you mentioned that you were doing a master's, right? Are you still doing your
Yep.
master's? So
Yep.
you're
Yep.
also enrolled at a university right now.
Yes, right now. So I'm almost done with my master's, hopefully by the end of this year. But I'm doing my master's. It's called the Master's in Analytics from Georgia Tech. And so far, I think in terms of kind of like my learnings, it's been pretty cool because you kind of get to implement, or it's basically more of like an applied analytics degree. And because I work in data quite a bit, you are exposed to kind of like the different approaches. The different approaches in analytics. So you have kind of like your descriptive analytics, you have prescriptive, predictive. So we kind of like explore all those different topics, and we are kind of like figuring out how do we implement data to solve like a business problem in this case.
Mhm.
Mhm.
So since you're based in Toronto and this is Georgia Tech, I assume.
It's in Atlanta, the United States, and I think it was also pretty interesting as well because my organization Home Depot is also based in Atlanta. So while I was taking the program, I did actually meet a lot of different Home Depot folks from the US that were also taking the program. So that's also how I guess I learned about all these cool open source technologies such as Data Build Tool. In this case, like picking up Python, picking up on the cloud, and a whole host of kind of like other tools that kind of like help me transition from kind of like being more of a business user to a software/data engineer in this case.
So when I was doing my master's was in business intelligence. It was more than 10
Mm-hmm.
years ago. No, it will be 10 years soon this year when I graduated from my master's. And when I was doing my master's, I was working as a freelancer. So it was a
Mm-hmm.
part-time job, sort of. So I would take a contract, do something, and then take the next one. So it was a part-time job. Like would spend like 20 hours per week. And yeah, I'm just thinking like you work full-time as a staff data engineer. This is must be not easy to do both things at the same time, right? How?
Yep. Exactly. Yeah. It's definitely like the one thing that really interested me about the Georgia Tech program was it definitely, based on the reviews that I read, it's definitely more on the what's it called, analytical rigor, because they do expect you to kind of like pick up on the math. They do expect you to kind of like learn Python as required. One of the courses that I took, we had to pick up D3, which is kind of like a JavaScript library. That was like a pretty intense as well, like because I at the moment I don't think people kind of like use D3, but it was just an opportunity for you to learn something new and pick it up and apply it. And in this case, like even when it comes to kind of like pursuing my master's, it was also important for me to kind of like just manage between my work and also just managing everything else that I have around me. So in this case, I try not to kind of like overwork myself. I try to take maybe like one course a semester. Uh, and I think it's also in this case trying to pick things that are related to my job, just so that just so that I can find opportunities to implement what I'm learning directly into my work. So that's kind of like been the value add there in this case, because as I'm learning whatever that I'm learning in university, because I work in a data space and analytics in particular, I can just kind of like take it and apply it immediately. So I guess that also kind of like helps me encapsulate my learning a little bit better. Yeah.
Because this is something we talked about. You also run, so you're into running, and you were running marathons this
Yep.
year. You're slowly returning to that. And like preparing for a marathon takes a lot of time.
Yep.
Then also doing a master's, then working, and then probably you still want to do something else apart from these things, right? Maybe
Yep.
go
Absolutely.
somewhere else.
Yep.
So the secret is you take one course per semester.
Uh, yep. Taking one course, and in this case, like when I was preparing for a marathon, I wasn't take. I think I maybe just I took maybe like also potentially like a lighter course. One thing I'll definitely say about my the analytics community at Georgia Tech is it's definitely really great as an online community because they have a Google Sheet where they basically take the course reviews and basically they do an average of how long or what's the estimated workload for each course. So my rule is I try to basically kind of like do the math. If I want to double up, my max is 20 hours. If a course is like 10 or 8 or 12, I think I can probably just take one at the time.
Mhm.
So it's pretty interesting because there are people that kind of like spend the time to build these set of tools that kind of like help you figure out how do you manage your workload. So I found that really interesting within the community as well. So, yeah.
It makes sense, right? So the course is about analytics, or the program is about analytics. So there
Yep.
should be some
Yep.
analytical ways of
Yep.
doing decision making in this
That's
case.
exactly. Yep.
I can see your cat
Ah, yes.
here. Um, so maybe last thing that I ask, and then we'll call it a day. So you mentioned that you're either recently or you're still preparing for a certificate in FinOps. Um,
Mhm.
so you have quite a few certificates, right?
Yep.
So are you actively investing in your time in extra learning in addition to um, what we just talked in masters, and
Yep.
how do you do this? Like,
Yep.
because again, like we have as humans only 24 hours per day.
Yep, exactly. And I think that was something that, yeah, I think it's applicable to everyone. So I think I would definitely say that I at least nowadays when I talk to folks that are kind of like interested in breaking into like data, I know a lot of folks that can take certifications, but at the same time, it's important for you to understand what certificates align with your interests and also something that you are truly passionate about. um so in terms of kind of like my learning, I guess it also comes with the territory that as a data engineer you kind of just have to the skill of learning is something that you kind of like
Yeah.
build as you go, right? So I think doing all this has helped me at least become a lot more efficient in terms of my learning and being having a strategy on just learning what I need to get the job done. So I think that
Mhm.
was kind of like a really important skill as I was kind of like embarking on my analytics masters, and as I kind of like learn to pick up the different certificates or the different programs that I'm doing. What I also found really helpful, at least in terms of building this habit of learning, it's also really finding your people. So I think in this case, I had a lot of there were a lot of things that kind of like were helpful for me in terms of keeping me consistent in learning. So one of the things that I only realized maybe a couple of years back was Toronto is also like a really big tech hub for data and analytics. So in the last couple of years, I've been doing my best to just attending meetups and learning from other people in the city. That's how you kind of like build your relationships and also kind of like get a sense of what the market is looking for. So you, as you kind of like ask and talk to other people, what are people using, what are people learning? That was kind of like how I kind of like at least build kind of like this support system around me to kind of like facilitate learning. So there's also kind of like in this case like the Data Talks Club where you guys kind of like host all these free learning sessions and uh, just kind of like going online, just kind of like learning from other people. The other part that I kind of also want to mention is also having the opportunity to apply what you learn. So I'm really fortunate, like in my organization at Kinaxis, there's an openness to building and applying the stuff that you learn from school. So shout out to my team, Emil and the rest of the folks at Kinaxis for just making the environment really great for just being able to learn and pick up new things. And lastly, I would say just kind of like having an accountability partner. So I have kind of like a monthly call scheduled with a friend that we talk through kind of like our goals. The person isn't even working in data. It just can be anybody. It can be your partner, but it just is a good way for you to always set up some sort of accountability system that you're just kind of like slowly progressing to your goal. Yeah.
Mhm. Yeah.
Yeah. And again, last one, I guess, to take this away, Alexei, is also just kind of like putting yourself out there and also giving back to the community. So what I really liked about Data Talks Club is you guys kind of like do this for free and you guys teach other people. And for me, the big step last year was just going on to ADP lists and signing up to be a mentor. So I've been also trying my best to just share what I know because I wished, like in my career 10 years ago, I wish somebody told me what are the things that I needed to learn as a data engineer and what can I do to get there faster, right? Because
Mhm.
I think a lot of data engineers are just too busy fixing
Yeah.
stuff that there's not really anybody to
Yeah.
talk to and share. So I hope to kind of like at least be the person out there that can hopefully inspire other people to kind of like take this path as well.
Yeah. Thank you, Eddie. It was amazing talking to you. thanks a lot for joining us today, for sharing your experience. Yeah, it took there were a lot of notes, so it was a very productive discussion. So thanks a lot for doing that. Now I know what FinOps is. I had no idea that this thing even existed. So thanks for taking your time, and it was really amazing.
Amazing. Thank you so much, Alexei. It was
Yeah.
great to be part of the talk today. Yeah.